This morning you walked outside and the sun warmed your face. You didn't think about it. Why would you? It's been there every single day since you were born. But what if one day it simply vanished? Not setting behind the horizon, not dimming behind a cloud, but swallowed by something invisible, something impossibly dense. The real answer is far stranger than you think. Let's start at the beginning. The sun is a star, a massive glowing ball of gas that burns hydrogen into helium at its core every second of every day. That process produces energy. That energy is keeping you alive from 93 million miles away. Think about that for a second. The light warming your skin right now left the surface of the sun 8 minutes ago. 8 minutes of travel through space before it reaches your nerve endings. Now imagine that light source stops existing. Not because it burns out, because a black hole swallows it. A black hole isn't some cosmic vacuum cleaner sucking everything into it. That's a common misconception. A black hole is simply a place where mass has become so concentrated that its gravity traps even light itself. German physicist Karl Schwarzschild calculated this back in 1916. He worked out the exact radius within which escape becomes impossible. Today, we call it the Schwarzschild radius. For the Sun, that radius would be about 2 miles. Sit with that for a moment. Our Sun, right now nearly 900,000 miles across, would have to compress down to a sphere just 2 miles wide to become a black hole. An entire star, crushed into something smaller than most cities. Hard to picture, isn't it? But here's the twist nobody expects. The Sun will never become a black hole. It simply doesn't have enough mass. For a star to collapse into a black hole on its own, it needs at least 20 times the mass of our Sun. Our star will do something far gentler instead. It will swell into a red giant, shed its outer layers, and leave behind a quiet white dwarf. No explosion. No dramatic collapse. Just a slow, silent fading that takes billions of years. So the real question isn't whether the Sun becomes a black hole. The question is, what would happen if an already existing black hole crossed paths with the Sun? That's not as impossible as it sounds. Our galaxy, the Milky Way, is scattered with black holes, and at its very center lurks a supermassive one named Sagittarius A star. Astronomers Andrea Ghez and Reinhard Genzel spent decades tracking stars orbiting an invisible object at the heart of our galaxy. Those stars curved and accelerated so sharply that only one explanation fit. A black hole with a mass equal to 4 million suns. Their discovery earned them the Nobel Prize in 2020. But that monster sits 26,000 light-years away. A far more plausible scenario is a smaller, stellar-sized black hole, somehow drifting into our solar system's neighborhood. So, what would actually happen? Here's the first thing worth knowing. A black hole wouldn't suddenly appear and swallow the Sun in an instant. Gravity doesn't work that way. If a 10 solar mass black hole reached the outer edge of the solar system, it would start with small, barely noticeable shifts in the orbits of the outer planets. Pluto and Neptune would begin drifting strangely off course. Astronomers would notice years, maybe decades, before anything dramatic happened. As the black hole drew closer, its gravitational pull would grow stronger and stronger. Planetary orbits would turn chaotic. Some would get flung out of the solar system entirely, like a billiard ball struck from the side. Others would spiral inward. And the Sun? The Sun wouldn't simply fall into the black hole. Instead, the two would begin a dance around each other, forming what's called a binary system. The black hole's gravity would gradually strip away the Sun's outer layers. Astronomers call this a tidal disruption event. Hot gas torn from the Sun would form a glowing disk around the black hole before spiraling in. That disk would burn so hot it would blast out X-rays visible across our entire galaxy. Stephen Hawking showed in 1974 that black holes aren't completely black after all. They slowly radiate energy, a process now called Hawking radiation. But, for a stellar mass black hole, that process is so slow it's practically meaningless on human timescales. The black hole that swallowed the Sun would still exist long after the entire span of human history had come and gone. What would happen to you here on Earth while all of this unfolded? Surprisingly, you wouldn't instantly freeze or burn. The process would stretch across years, maybe decades. As the Sun kept losing material, its brightness would start to swing wildly. Some years would turn unusually hot from the released energy. Others would plunge into bitter cold. Agriculture would collapse. Civilization as we know it wouldn't end from sudden darkness. It would end from unpredictability. And eventually, once Earth's orbit turned unstable too, it would either spiral into the disk or get flung into deep space, where no star remains to warm it. A frozen planet, drifting forever through the dark. This is usually where people shudder and change the subject, but there's something strangely comforting hiding in all of this. Physicist Roger Penrose, who also won the Nobel Prize in 2020 for his theoretical work on black holes, often pointed out that black holes aren't symbols of destruction at all. They're one of the most predictable, orderly phenomena in the entire universe. There's no chaos inside them, just physics, followed to its most extreme and consistent conclusion. And here's the modern mirror you probably didn't expect. You live every day on a planet orbiting a star, itself held in a fragile, accidental balance. The gravity pinning you to your chair right now is the exact same force that becomes infinitely compressed inside a black hole. There's no difference in the laws of physics between the two, only in the scale. Next time you step outside and feel the sun's warmth on your face, remember this. That warmth is the result of a balance that feels eternal on a human timescale, but is only a passing moment on a cosmic one. The sun will never become a black hole. But somewhere out there, in another corner of your galaxy, that exact process is happening right now to a different star. And if there were beings on a planet orbiting it, they'd be watching their own sun slowly disappear. This morning you walked outside and the sun warmed your face. Now you know that warmth was never something to take for granted. It's just one brief, warm moment inside a much stranger, much larger story, one that began long before you existed and in which you are only a fleeting flicker of warmth yourself.